So welcome to lecture number 3 for our Math 140 series. Statistics for business majors. This is February 1st, 2022, and we are starting chapter 2, describing distributions with numbers. And while everyone's here, let's plan to have a quiz on chapter 1. And it's only going to be like a few questions. It's not going to be a long quiz. But let's plan to have the quiz on Thursday. Let's make it on Tuesday. Quiz on Tuesday on chapter 1. That way it'll be after the homework is due. So you'll have the opportunity to finish all the homework. So we will have our first quiz a week from today on chapter 1. Now, chapter 2. So the question is, what exactly is a distribution? Does anyone recall what a distribution is? At least in the context of a sample. Not everyone at once. It's kind of hard to hear everyone talk at the same time.
Isn't it just how the samples are distributed across, the shape of them, basically?
Well, when you say the shape of them, the shape is a way of describing a distribution. Symmetric, left skewed, right skewed. But what is a distribution in its own right? If I asked you to define a distribution, you can't reference different types of distributions as part of your definition of what a distribution is. So what is a distribution? It is the collection of all the outcomes together with the frequency for each outcome. How many blue-eyed people are there? How many green-eyed people are there? How many brown-eyed people are there? How many people fall in this category? How many people fall in that category? And so on. So the distribution are the actual outcomes of the sample together with how often each outcome occurs. And depending if it's a categorical variable or a quantitative variable, we would use different visual displays for our distributions. We saw last chapter, pie charts and bar graphs for categorical variables and stem plots and histograms, among other displays for quantitative variables. So now we also saw last time ways of describing a distribution: shape, center, spread, and outliers. And those were very qualitative, even a little bit quantitative. And the spread is from this number to that number, and the center, it's over there approximately. It's where the balance point is. But now we want to get a little more mathematical so we can get more precise. So when we describe distributions with numbers, we're going to start with the most important aspect of any distribution, which is the center. Where is the center of the distribution? And what we mentioned last time is if you have a distribution, maybe you have a histogram that looks something like this. Maybe you have a histogram that looks like this.
Professor, the center would be the balance point, correct?
Yeah, exactly. So if you want to do it in a non-mathematical way, then the center, a way of thinking about the center is actually constructing the distribution from some material, wood, steel, something like that. You have an actual physical construct, and you're going to put your finger underneath the point where the construct would balance. That would be the center. And now we want to describe the same point mathematically. So, if the center is over here, let's say the balance point is also equal to what is called the mean of the distribution. Technically, it's called the arithmetic mean because there is another type of mean, at least one other type of mean that I know of, possibly even others. The book doesn't say arithmetic mean, it just says the mean. And how do we find the mean? The mean is equal to the first data value plus the second data value, and we add up all the way to the nth data value, and then we divide by how many data values we have. So if I have 100 data values, I would add them all up and divide by 100, and that's how I would compute the mean. This is like in third grade when you took 2 tests and you said, hey, what's my average? How do you average your test scores? You divide them up and divide by how many tests you took. That's exactly what we talk about when we talk about the mean. And the symbol that we use for the mean when we use X for your data values is X bar. We put a bar on top of X, and this is called technically the sample mean. So the
Did
balance.
you just call it-
Say again?
Isn't average the same definition as a mean?
Average is a bad word to use because we're going to see that there's different types of averages. And when you talk about average or you hear an actual report in the news online and they use the word average, you have to be very, not suspect, but have to be very careful because when they say average, they can mean a variety of different things. They can mean the median, they can mean the mean, they can mean the mode, they can mean other things. So we want to be more precise. We don't want to use the word average. We're going to use the word mean for this particular definition. Does that make sense?
Yeah, no, it makes sense. I'm just saying that most people commonly know it as the average.
Exactly. But here in the statistics class, we don't call it the average because it's not. It's a average. It's one of a few ways of computing an average. But it is not the average.
Yeah.
Okay.
In a stats class, is there a preference to which average is the best?
Sure. Different distributions, as we're going to see, sometimes the mean is preferable. Sometimes the median is preferable. And we're going to see, I think in this chapter, almost certainly in this chapter, in which situations we want to use one and in which situations we want to use the other.
Okay.
For now, we're just defining them. Another way of writing this, a different notation, is sigma notation. Has anyone here not seen this notation before?
I've seen it. I just don't know what it means.
Okay, so this guy here, what it means is sum, which is why we use the Greek letter sigma for sum, because apparently if things start with the same letter, they must be correlated. So we use sigma, the sum of each x sub I as we range from I equal 1 to I equals n. So I'm summing starting from the bottom I equals 1. I'm starting at x sub 1. I'm going to add x sub 2. I'm going to add x sub 3 all the way up to x sub n, where the symbol above the notation tells me when to stop. So for example, if I had the summation from I equals 3 to 5 of I squared, this would be 3 squared plus 4 squared plus 5 squared. It's telling me to sum starting from I equals 3 and ending at I equals 5, the quantity I squared. So 3 squared, 4 squared, 5 squared, and add them together. In our example, I'm summing x sub I, so x sub 1, x sub 2, x sub 3, all the way up to x sub n. It's just a closed form for x bar, so I don't got to use this ... notation. But if you're happy with the ... notation, you certainly can use it. We don't ever need this summation notation in this course. Yes, Mark.
Professor, are you allowed to bring back the that bottom part again or no?
Oh, the thing I just erased? Yeah. If you
I'm
this
so
one here?
sorry. So in this case, that because it says I3, correct?
Yeah, so that means start at 3.
Start at 3 and then the sigma or what? Sigma is the E?
Sigma's it's the Greek letter. It's the Greek letter. It kind of looks like that. And it
And
tells
that's where you would want to stop, correct?
no, you stop at the number on top of it. You stop at 5. So I started I equals 3 and I end the number on top, which is 5.
Okay.
And what am I summing? I'm summing whatever it tells me to sum, which is I squared.
Got it.
So sum
Okay.
3 squared, 4 squared, and stop at 5 squared. So
Wait,
20
can I write that down very quickly?
no, I can write it very slowly though.
Professor,
Yeah,
Thank you.
the question. So the X with the line over it, that's also known as sample mean.
yeah, in this course, the X bar, and pretty much every statistics book I've ever read, the bar notation is for the sample mean. So X
What's the
bar,
proper term for that?
sorry,
What's the proper term to say it?
X
For the
bar,
X bar. Just X bar?
X bar, yeah. Yeah, X bar. We're gonna have later in the course this, which is X twiddle. And then we're gonna have X bar, X sub I, or just X. These are all gonna mean different things. We're gonna have X sub 0, that's gonna mean something different. So every one of these means something specific, and you have to know when you come across it exactly what we're referring to. In this case, X bar is the average, the mean average of all of the X sub I data points. Okay, with me so far? Question,
Yes.
comment, metaphor, simile, allegory? Anything? Okay, so the next measure of center. Another measure of center is the median. And the median will be denoted either by capital M or by Q2. And the Q2 notation, the reason for that will become evident later. But the median, either capital M for median or Q2. So the median is a little tougher to compute than the mean because it requires us to do a little work. Step one.
Hey, boss. Oh,
Yeah.
my bad for coming in late.
That's Steve.
Yeah, I had a problem with my computer. I went to go check it out at Best Buy, and I had to like fix it a lot, so that's why I didn't come in. And I barely got it right now. That's why.
Well, that sounds like a great story that I'd love to hear another time.
Yeah. So
I'm glad that you're here with us now.
yeah.
All right. So step one, sort the data from lowest to highest. Sometimes when you're provided data, it will already be sorted for you, in which case you can skip step one. If not, don't skip step one and sort the data from lowest to highest. The median is equal to data point number n plus 1 over 2, i.e., if the data is x1, x2, all the way through x sub n, then the median is x sub n plus 1 over 2. So note, if n is odd, then x sub n plus 1 over 2 is just the middle value. Let's think about that. If you have x1, x2, x3, x4, and x5, as an example here, then what is n equal to in this case? How many data points do I have?
5.
Yeah, 5.
5. So what is n plus 1 over 2?
3.
3. And therefore the median is just x of 3. It's the one right in the middle.
If it was a 1 through 6, could we assume that?
Ah,
Yeah,
so
yeah.
now, if n is even, then x sub n plus 1/2 is the mean of the two in the middle. So for example, if we have x1, x2, x3, x4, x5, and x6, then what is n equal to?
6,
So what is n plus 1/2?
3.5.
3.5. So therefore the median is in between these guys. Average, I see, now you got me saying the word average. Take the mean of x3 and x4, i.e. x3 plus x4 divided by 2.
Professor,
Yeah,
I might be looking into it too much, but I see why in the equation you have to divide by 2, but why do you add 1?
because if you don't add 1, you don't get the right data points. I mean, look at the first example when it's 5. If you just divide by 2, then it's 2.5. But no, the median's the third one.
So it's just a rule we have to accept.
It's the, yeah, you don't technically need the rule if you understand that if it's odd, it's the one in the middle, and if it's even, it's the average of the two in the middle, the mean of the two in the middle. But if you want to have a mathematical rule, this is it.
Okay.
Okay, the median is the data point corresponding to the n plus 1/2 data points when they're placed in order from lowest to highest. Make sense?
Professor?
Yeah.
So like when you got n for 6, you basically that's just like those two. You just, that could be any two numbers for 3 and 4. So that could be like 3 and 3 or 4 and 2.
Well, I don't know what the numbers are. I just know it's a third and fourth data point. So I have no idea what the numbers are going to be. I'm not saying the median is 3.5. The median is the mean of the two data points that are in the center. Let's do an example from the actual book with actual numbers. So let's see how that works. So you have the following data set: 5, 10, 10, 10, 10, 12, 15, 20, 20, 25, 30, 30, 40, 40, and 60. Now I've already set them up in order from lowest to highest, so we don't have to worry about that. And I want to find the median. So if they're already in order from lowest to highest, then the first thing I should do is count how many I have, calculate what n is. So what is n in this example?
15.
15.
Yeah.
So what is n plus 1/2?
8.
8. So the median is the 8th data point. 1, 2, 3, 4, 5, 6, 7, 8. The median is that guy.
Professor, how did you get, I'm so sorry.
Yeah, go ahead.
How did he get 15?
I counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
So we would just get the middle of this whole row of numbers.
Well, those are my data points.
Okay.
Right? These are, I don't know what the survey was. I don't know what the sample was. I don't know where it's coming from. I just know that these are my 15 data points. So the question is, okay, if these are your data points, what's the median? And the answer is, well, there's 15 data points, n plus 1/2 is 8. So it's the 8th one. By the way, what's the mean?
Wouldn't you have to add them up all together and divide it by 15?
Yeah. So I just did that. And I got a mean of, so by the way, the mean x bar is equal to 22.46 bar. That bar, by the way, under the six, on top of the six, got nothing to do with the bar on top of the X, right? The 6 bar just means 6 repeating as a decimal. And the X bar means it's the average of the X's, and nothing to do with each other. So the median is relatively close to the mean, but it's a little smaller.
Is capital M usually used to mean medium and X bar is for mean?
X bar is the sample mean always. And usually I would use Q2 for the median. Your calculator, by the way, the TI-84 uses Q2 when it computes the median for you. But in this textbook, either capital M or Q2 is an acceptable, or even just writing out the word median is completely acceptable for median.
Okay, thanks.
All right, so that's a situation when n is odd. So let's do another example now when n is even. So here's another situation where we have the following data points. And these ones, the book is an asshole. It is not giving me the data points in numerical order. So as my first step, I will have to place them in order, or I cannot compute the median. Now, if I use my calculator can actually do both. Your calculator can both sort and compute the median, whether or not it's sorted, which is really nice. And as we progress in the course, we're certainly going to use the calculator for quite a few calculations. For now, if you want to use the calculator, does anyone have a TI-84?
Yeah.
Okay,
Yeah.
if you want to use it, you should hit stat. Stat is in the center on top. It's the third row, stat. And then you'll come to a screen like this, and the screen has edit highlighted. So you don't got to do anything, just hit enter. And then you are going to have a list, have a screen that looks like this. And you're going to put all your data points in list 1. So 10, 30, 5, 25, 40, 20, 10, 15, 30, 20, 15, 20, 85, 15, 65, 15, 60, 60, 40, and 45. And I just put in my calculator, and it also tells me that there's 20 data points. So we have an even number of data points. And then
Do
if
we do this? I'm sorry. Could we use Excel to do this?
well, not on the tests. If you want to use Excel now, you're more than more than welcome to. But when it comes to tests, you're not going to have Excel at your disposal. So
Okay.
you might want to get used to it. Now, if you hit stat again and have it sort A list 1, and then you go back to stat and edit, you see now that it put them all in order for me.
What do you do after you put it out again? How did you get it to sort?
Hit stat and then go down to sort A, sort ascending, hit enter, and then hit second. On the top left, you see in blue second. And then on the bottom, hit L1, which is right above your 1 button. And hit enter. It should look like this. Sort list 1, it'll say done. And then if you go back to stat and edit again, now the same data points are going to be in order. 5, 10, 10, 15, 15, 15, 15, 20, 20, 20, and then 25, 30, 30. And remember, these are all on YouTube. They're going to be on my channel, so you can always watch these later. And when you get a calculator, 60, 60, and 65, and 85. Okay. Is 31.25 the mean? No, let's take a look. Is 31.25 the mean? What does my calculator say? Yep, 31.25 is the mean. But the question is, what's the median? Oh, actually, the calculator, I thought the calculator gave Q2, but the calculator actually says MED. So MED, the median, M, Q2, median, any of these, they're all saying the same thing. How do we do it? Well, there's 20 data points, which means what's n?
20.
20, yeah,
So what's n plus 1 over 2?
11.
No. If there's an even
10.5.
10.5. N is 20, n plus 1 is 21, n plus 1 over 2 is 20
22, yeah.
is 10.5. So we're looking for the 10.5th data point. In other words, halfway between the 10th and the 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So halfway between them would be a median of 22.5. Notice that the median is not one of my data points. So be it. The median is not one of my data points either. By the way, X bar equals to, I lost it here. Well, he told it to me, 31.25. You and Khan Academy has to do a collaboration. What would that collaboration be? Khan Academy sucks and I'm awesome. So what exactly are we going for here? Of course, I'm also not really modest. So in that regard, I'm, it's always give or take, but. Does that make sense though? 31.25? I could teach them some stuff. Stupid Khan Academy. Oh, don't get me started on Khan Academy. Trust me, all these online platforms with, hey, let me teach you just a little bit and pretend like you know what you're talking about now. And not go into any depth or really give you any hard problems to make sure you truly understand it. Let's not do that because that would just discourage you. So let's keep it shallow and superficial and you go out thinking you know it, but you don't really, so you fail your test. Breathe. Okay. I'm better now. So are there any questions with mean or median?
So for the median, all you did was go to the point of the between 10 to 10.5, right?
Yeah, this is data point
So
number
20 and 25, and then you take half of that, which is 22.5. That's how you got.
I don't like your terminology. I didn't say half of that. I took the mean of those two values.
Okay.
I added them and then I divided by 2.
So if, for example, if it was like 20 and 30, would you say the median was 25?
That's exactly what I would say. That's right.
Okay. Okay. Thank you.
Okay. All right. Yeah.
Question, Professor. So you said we can't use obviously Excel on the test. Can we use an calculator app on our phones?
I can't allow that because phones, what else you're using if you're on your phone? So no, it has to be a calculator.
I was gonna ask, it's
But-
basically the same thing as
Yeah,
what's it called?
go ahead.
Algebra, right? Like the median.
Mean and median are simple calculations. And I mean, obviously the calculator can do them faster and have less chance of error. But
What if I can do it faster?
well, I would go to the Magic Castle and try to make an act there. That's what I would do.
So,
Maybe I should try that out.
Okay. Listen, I mean,
so Professor,
yeah,
sorry to interrupt. So the mean is just you add everything divided by the amount there is, and median is just n plus 1 over 2. That's it.
no. The median is not n plus 1 over 2. The median is the data points in the n plus 1 over second location. N plus 1 over 2 here was 10.5. The median is not 10.5. The median is a 10.5th location.
Oh, so it's just a coordinate for the, okay,
It's halfway between the 10th and 11th data points.
okay.
Okay, so that's why we get 22.5 for the median.
Cool.
You can use any calculator you want. My preference is the TI-84. For stats, at least, I personally don't use it as my regular go-to calculator. I even use the Packard that I prefer, but I do recognize that amongst statistical operations, the TI-84 to me is the simplest calculator on the market, and it's the one that most colleges tend to use in a lot of their classes. And as I mentioned in the first lecture, the TI-84 has a lot of staying power. So if you buy it and then you want to sell it later, you'll basically be able to sell it for exactly what you bought it for because the prices just have been stable for 20 years. It's going to be used next year. It's going to be used the year after. It's just the price is never going to go down. Unless they come out with some new one, which they haven't done in forever. So whatever you spend on it, you should be able to recoup that when the semester is over. All right, so next question is when do we use the mean and when do we use the median? Mean versus median, battle royale, mean versus median. Who is gonna win? When do we use each one? So, if you have a distribution which is fairly symmetric, now let's actually start with perfectly symmetric. So let's say I have a distribution that looks like this.
Ya te reacciona.
No te regresaron dinero.
¿Ah?
Te regresaron dinero.
¿Cuál?
Te regresaron dinero.
My bad.
I just thought that conversation was fascinating. I just didn't understand a word of it. But let's say you have a perfectly symmetric distribution. Where is the mean in this distribution?
Right in the center.
Right in the center, perfectly the balance point. Where is the median in this distribution?
Right in the center.
Right in the center. So when it comes to a symmetric distribution, then the mean and the median are going to be the same. So I don't care which one you use because they're going to be the same. What if instead I have a distribution that looks more like this? Okay, what if I have a distribution like this? Is this a symmetric distribution?
No,
Is it skewed right or skewed to the left?
right.
Right.
Okay, so this is skewed right. So where is the mean and where is the median, approximately at least, in a distribution like this?
Would the mean be more on the left and then the median be more on the right?
Well, it's a good guess, but no.
Wouldn't both be on the left?
Again, good guess, but no.
The mean would be more to the left, the median would be right in the center.
Good guess, but no. So let's think about it. If this part was not there, let's ignore that first. Don't erase it because I'm going to put it back in a minute. But if that part was not there, where would the mean be?
In the middle?
Right in the middle of the 5 columns that are remaining, correct? Approximately at least, right?
Yeah.
So let's not forget that the mean is the balance point. So if I add to my physical constructs, all of those columns on the left, what's that going to do to the balance point? Move it which direction?
Right.
It's going to move it to the right. With a right skewed distribution, the mean is going to move to the right. It's not going to move all the way to the right. So if when you guys were saying what's on the left, you meant as opposed to being all the way on the right. And I said, no, I wasn't trying to shoot that down. It still is going to be leftish overall, but I would say the mean now, rather than being where it was before, would be somewhere around there or so. It would have been pulled to the right due to the long tail on the right side. The median, on the other hand, while it might move slightly to the right, it's not going to move nearly as much as the mean does. Because if you add up every value and divide by how many you have, then having really, really, really big values is going to raise your mean considerably. But if you just align them in order from lowest to highest, it doesn't make a difference how much higher those numbers in the right are. They're just the highest number of my distribution. And as such, I don't care how big it actually is. It could be 1,000,000 for all I care. That's not going to affect the median any different than if it was 100. It's just the biggest number. So the median might also go to the left, but not nearly as much. So when you have a right skewed distribution, as a general rule, and certainly for this course, the mean will always be pulled further in the direction of skewness than the median. Always. As a result, when you have really, really skewed data, you don't want to use the mean because the mean is affected significantly by those really, really big numbers. The median is the one that you want to use when the data is skewed or there are outliers. Whereas the mean is the one you want to use when it's symmetric and no outliers.
Why wouldn't you want to use the median if it was symmetric or no outliers?
Well, if it's symmetric with or without outliers, I mean, in general, if it's symmetric, the mean and median are going to be close anyway. But I don't mean exactly symmetric. If you have a graph that looks like this, so here, and then this, and then this, and then that, all the way out there. This is a fairly symmetric graph. It's got one little outlier on the far right. But that little outlier is seriously going to raise the mean and barely touch the median at all. So that outlier, unless, I mean, presumably that outlier is not representative of the entire population. And as such, your measure that you're using to denote the center when you include it, you want to limit its effect on the overall representation that you're giving to your data. So you want to use a measure that's not as affected by these abnormally large values. We say that the median is a resistant measure. The median resists abnormally large or abnormally small values. The mean is a non-resistant measure. The mean is affected very much by abnormally large or small values. And as such, we don't want to use it when you have abnormally large or small values. In other words, when you have skewness or you have outliers. In that case, you want to use the median, which resists those outliers and the skewness a lot better than the mean does. So that is your determining factor in this course for which measure of center you want to use. There is a third measure of center called the mode. The mode, anyone know what a mode is? Oh, wait, I saw a cat. What's the cat's name?
Sausage, as she is a tortoiseshell cat.
Her name was Sausage. Is that what you just
Yes,
said? Sausage.
sausage.
Interesting. Now I'm even hungrier. Great. Okay. So the third and least useful of the three measure of center is the mode. Anyone know what the mode is? Yes, the mode is the number that occurs the most often, number or class. You could have a modal class if it's a histogram that occurs the most often.
Professor, is range not used? Do we not use it in?
Range is not a measure of center. Range is a measure of spread. And yes, we will use the range, or at least we'll mention the range. It's not really a good one, but the range is not a measure of center. It's a measure of
Professor,
spread. Yes.
if there was a symmetrical histogram or anything and there were no outliers, could you use mean and median interchangeably?
If it's perfectly symmetrical, then yes, you get the same value. If it's approximately symmetrical, we do prefer the mean, because from a mathematical perspective, the mean is the math that you can do with the mean is a lot better than the math that you can do with the median. So we do have a bias towards using the mean. We want to use the mean, and we use it unless we have a reason not to. And those reasons not to are skewness and outliers. So in a situation when you can use either one, use the mean.
Okay.
The third is the mode. The mode is the number or class that occurs the most often. If a number occurs, if two different numbers occur the most often, we say it's bimodal. So the data can be unimodal or bimodal, or not have a mode at all. We don't say it's trimodal or quadrimodal or quantumodal or whatever. I don't even know how it goes from there. Either none, one, or two. If there's three that occur the most often, or four or five, we just say there's no mode. But out there in the world, if someone says, oh, I did a survey and the average is 7, then the average they could be referring to might actually be a mode. There is that possibility, which is why you have to look into the context of the situation to determine, is it the median? Is it the mean? Is it the mode? If it is the mean, which type of mean? Is it the arithmetic mean? Is it the geometric mean? Is it this? Is it that? And so on. But in this class, we're going to keep it simple. There's the mean, there's the median, and there's the mode.
Professor, is the mean a resistant measure and the median is a non-resistant measure?
No, the median is very resistant. It's hard to change the median. The median resists changes. If I have this data point, 3, 5, and 7, what's the median?
5.
Oh, I meant 87. What's the median? It's still 5.
Right.
Okay, the median is very little or completely unaffected by abnormally large numbers in place of representative numbers. But if I ask you for what's the mean of these three numbers, what's the mean of these three numbers?
7.5? No, yeah,
No, it's 5.
7.5.
5.
5.
You add them up and divide by 3, right? 3 plus 5 plus 7.
Oh, shit. Yeah, divide by 3. My bad.
What's the mean of those three numbers?
Changes a lot.
Significantly
lot.
higher.
It changes a lot. The mean is non-resistant. It's easy to change the mean. It does not resist changes. The median resists changes very well. So the median is a resistant measure and the mean is a non-resistant measure. And the mode.
So in this,
Go ahead.
so in this example, it looks like the mean likes to it likes to freak out a lot. So why do we still prefer it over the median if we can choose?
Because the mean has better theoretical properties than the median does in ways that are way beyond the level of this course.
Oh,
So,
Sure.
I mean, you've taken, who's talking right now? Peter? Okay, someone else was mentioning earlier that they took calculus. Calculus is a very powerful tool in mathematics and allows us to do some really amazing things. And the calculus techniques that we learned for the mean work very, very well, and for the median, not so much. So a lot of
So
our,
if you're adding another data point, then it gets reversed, right? The mean is much more resistant than a median.
Not necessarily, not necessarily. Let's see, I have the following, 1, 2, and 3. All right, we'll keep it like that. So let's add, so what's the median right now?
2,
2. Okay, I'm gonna add 100. What's the median right now?
3.
Well, no, it's 2.5.
Oh, 2.5, yeah.
All right, didn't change that much. Right, didn't change, 2 to 2.5, not that much of a change. Now, what is the mean right now?
2.
What's the mean right now?
I don't know, 104 divided by 4.
20 something,
53.
right? 20, 23, 24, 25, whatever it is, right? it changed a lot. Right? Adding a data point didn't affect the median that much, but it affected the mean a lot. Agreed?
Yeah, in that example, correct.
In that example, right? Yeah. I mean, if I would have done this, if I would have added another 2, then in this case, the median is affected and the median, the mean stays the same and the median goes up a little bit. I'm not saying every example is gonna always follow this rule, but in general, it does work that way. In general, the median is hard to change and the mean is easy to change. So the mean is non-resistant, the median is resistant.
Okay.
That's a general rule. Okay. So those are our measures of center. So now the other consideration for distributions is spread. We want to measure spread, how spread out the data is. And we have various measures of spread, starting with the range. The range is nothing more than the max minus the min, the biggest minus the smallest. The reason why we don't like to use the range as a representative measure of a spread is because one outlier will do what to the range. If I have 1, 2, 3, and 100, what does that 100 do to the range?
Skews the hell out of it.
It skews the hell out of it. So the range is very non-resistant. Okay, the range is extremely non-resistant. You have one big number, one small number, your range will change considerably. So the max minus the min is not the preferred measure of spread. What we do instead is we define what is called the IQR, which is the interquartile range. And this is defined as the middle 50%. In a very specific way. We're gonna get it exactly. The interquartile range is essentially the middle 50%. We're gonna call it Q3 minus Q1, and I'm gonna explain how to find Q1 and Q3 in a second. But it's a number. So when I say middle 50%, I don't mean, oh yeah, the interquartile range is 26 to 92. No, it's a number. It's this minus that. The interquartile range is essentially representing the middle 50%. If it's the middle 50% and you add a big number or a small number, what will that do to the IQR?
Nothing.
Nothing or a minimal amount. So the IQR is a resistant measure. And that's why we like it so much in comparison to the range, which is a non-resistant measure. So how do we go about and find the interquartile range? And the answer is very, very simple. Step 1, find the median. Step 2, find the median of what's to the left of the median. This is Q1. So you first find the median of all the data. Then you look at everything to the left of that and you find the median of that. That's Q1. Can anyone think of how we find Q3?
The median right of Q2 or the median, the first median.
Exactly.
But like you gotta add them now. If you subtract it from one side, you would even.
Well, we find the median of what's to the right of Q2. Can you explain? Yeah, I'll do an example. First write down these steps and then I'll do an example to demonstrate. Find the median of what's to the right of Q2. This is Q3. And then the IQR is just Q3 minus Q1. The interquartile range, the IQR, is the third quartile, Q3, the third quartile, minus the first quartile. Essentially, what we do is we divide the data. Here's the min. Here's Q1. Here's Q2, here's Q3, and here's the max. We divide the data. This is called this is called a box plot. We'll get to that shortly, but since it pertains to what we're doing here, I might as well do it. This is called a box plot. And a box plot has two dots, two lines, a box in the middle with a vertical line in the middle of that, or somewhere in the middle of that. And the 5 numbers that are used to form the box plot are the minimum value, the first quartile, the second quartile, the third quartile, and the maximum. So roughly 25% of the data will be between the minimum and the first quartile. 25% will be there, 25% will be there, and 25% will be there approximately. So the interquartile range gives us the middle 50% of the data.
Why do you say roughly 25%? Because isn't it supposed to represent all of the data, or?
Yeah, but what if you don't have a number that's divisible by 4? All right, if you have 19 numbers, it's not going to be exactly 25%, 25%.
Oh, I see. Okay.
So it's approximately 25%. Okay. So let's do an example to then to clear up hopefully all of this stuff. Let's do the 2 examples that or at least one of the examples that we had earlier. We had the following data: 5, 10, 10, 10, 10, 12, 15, 20, 20, 25, 30, 30, 40, 40, and 60. So, what's the min of this data?
5,
5. What's the max?
60.
60. So let's make a number line that goes from, let's say, 10 to 70. So we get everything: 30, 40, 50, 60, and 70. And what we're going to do is we're going to put a dot here at 5. And we're going to put a dot here at 60. That's the min and the max. Now, well, what did we say step 1 was? Find the median. Okay, so we did this example before, so we should already know what it was, but let's get a little practice. How many data points are there here?
15.
15. So n is 15. So what is the n plus 1 over 2?
3.
No, n is 8. N is 15. N plus 1 over 2 is 8. No? 15 plus 1, 16 over 2 is 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. So this number here, this guy is my Q2. That's my median. Do we agree?
Yeah.
Okay, so we put a little vertical line at Q2 at the median. Now, how many numbers are to the left of the median?
19 or 20? Well, less than 20.
Hold on. How many data points are to the left of the median?
7.
7.
7, right? 7 data points to the left of the median, correct?
Yes.
So what's the median, sorry, of those 7 data points?
3.5.
Well, it's a 3 point, wait a second.
3.5 data points.
Oh, hold on. N is 7, right?
Mhm.
Add 1 and divide by 2.
2.
What do you get?
2.
Add 1 and divide by 2. What do you get?
4.
4. So the 4th data point, which is this one, that's my Q1. So I put a vertical line, and I know, Phil, I saw you in there, but I wanted to walk through it. There's a 10. So that's the left half of my box, and that's my line, my whisker. Used to be called a box and whisker plot. Now, go back to the median. How many data points are to the right of the median?
7,
7. What's n?
7,
So what's n plus 1 over 2?
4,
So the fourth data point, 20, 25, 30, 30, this one right here, that's my Q3. And that is my box plot.
Do you want us to label like Q2, Q1, Q3, or do we
Don't-
not have to?
You don't have to label them in the box plot. Those vertical lines tell me that I'm dealing with Q1, Q2, and Q3. So you don't have to label them in the box plot, but if you're first learning this and you're trying to correlate the numbers in your data collection to everything, then you might want to label it just for your own benefit. Also notice that I don't just say that the 10 is the Q1, it's the third 10 that's Q1. It's the first 20 that's Q2. It's the second 30 that's Q3 and so on. I care which one so I can make sure that I have the right amount to the left and to the right and so on. So this is the box plot for this data. And therefore, what is the IQR?
20.
30. Oh yeah, 20, 20.
The IQR is Q3 minus Q1, so the IQR is 20. So the interquartile range is 20. Q3 minus Q1. Agreed?
Yeah.
Okay, now, what's really nice about this approach is using the IQR. We have a mathematical way of determining suspected outliers. We have a mathematical way of determining suspected outliers. I think this is an outlier. Well, let's confirm. So what is our method for determining a suspected outlier? Step 1, calculate the IQR. In our example, we calculated the IQR. What did we get?
20.
20.
Right, in our example, we got 20. Step 2, calculate the IQR times the number 1.5. Where does the number 1.5 come from? It comes from people a lot smarter than you and me who decided that 1.5 was the right number to use. I do not know. I have never seen any paper or derivation for why 1.5 is to be used versus anything else. It is what we use in this class, and it is what we use in every book I've ever seen. I do not know why specifically it's 1.5 and not 1.4, 1.6, or some other number. The powers of statistical analysis have decided that 1.5 is the correct value. So in our example, what is IQR times 1.5?
50.
I don't think so.
30.
30. 20 times 1.5 should be 30. Which, Philip, you said Q3. It happens to be the same number as Q3, but that's a complete and utter coincidence. In general, it's going to be, I mean, it could be anything. But in this case, it happens to be 30. Q3 happened to be 30. That's a pure coincidence. Step 3. Calculate Q1 minus this number that we just got. In our example, what is Q1 minus that number?
20. Or negative 20.
Negative 20. Step 4, calculate Q3 plus that number. In our example, what do we get?
10.
Try again.
30 plus -20.
No. Sorry, not -20. It's this number I'm using for both here and here. Sorry if I was not clear. It's this IQR times 1.5. That number I use both in step 3 and in step 4. I don't take what I
Oh, okay. So you don't use the value from 3
No,
into number
I
4.
don't use that value -20 again. It's just I'm using the same 30. So what is Q3 plus that number? 60.
60.
The values from step 3 and 4 are the cutoffs. Anything past them is a suspected outlier. In our example, do we have any data points past -20 or 60?
No.
No. So in our particular example, there are no suspected outliers.
Professor,
Yes.
since we established that the range is going to be the smallest and largest number, wouldn't there
No,
mean
wait. The range is the biggest minus the smallest. The range is 55.
Oh, no. I'm sorry. I meant when we made the whiskers,
Okay.
like so why would anything be past it if we determine that all the possible numbers are going to be between 5 and 60, and it's saying that anything out of 60?
Well, because I'm not using. Well, here, let me give an example. Let's do another one that has an outlier. So that way you can see it in action. So, okay,
I'm so sorry, one more question.
yeah,
In regards to step 3 and 4,
okay.
does that mean Q1 minus 1.5?
No, Q1 minus IQR times 1.5.
Got it. Okay, thank
This
you.
whole thing appears here and appears here. Okay, so let's do another example. This is the other one that we did earlier. I'm going to repeat it. My data is 5, 10, 10, 15, 15. 2 more 15s. Then I have a 20, 20, 20, 25, 30, 30, 40, 40, 45, 60, 60, 65, and 85. So let's make our box plot, which involves finding Q1, Q2, Q3, the IQR, everything. So what's the min?
5.
What's the max?
85.
85.
Okay, so let's make it from 0 to 90. 10, 20, 30, 40, 50, 60, 70, 80, and 90. Get it all. Okay. Okay, so we have the min at 5 and we have the max at 85. We agree with those two?
Yes.
Let's find the median. How many data points do we have here?
20.
The medium is 20.
No, the number
There's
of
20 data points.
There's 20 data points. That's my n. N is 20. Add 1, divide by 2. What do I get?
10.5, right?
10.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The median is right here. That's where
22.
Q2 is,
22.
right. Q2 is right here at 22.5. So that is my vertical line for Q2. Now, how many data points are to the left of Q2?
Um, 10, right?
10. 10.
So if n is 10, what's n plus 1 over 2?
5.5.
5.5. So 1, 2, 3, 4, 5. So Q1 is right between those two. So what is Q1?
The same number, 15.
15. Okay, so this makes the left box, and that's my whisker. How many data points are to the right of Q2?
And
10,
Good.
which means n is 10 and plus 1 over 2 is 5.5. 1, 2, 3, 4, 5. So Q3 is halfway between 40 and 45. So what's Q3?
2.5.
42.
42.5.
Okay, so there's Q3. And there is my box and whisker plot. What's the IQR? It's 42.5 minus 15, which is
27.5.
27.5. So what is the IQR times 1.5?
Uh, 41.25. 41.25.
41.25. So just looking at the graph, if I go from Q1 to the left by 41.25, any data points past that number? Q1 was what, 15 minus 41.25? That is less than 5, is it not? Which is our lowest data point, right? What is 15 minus 41.25?
Negative 27.25.
Negative 26.25.
Oh, yeah,
Right?
it's 41. Yeah.
And if I go to Q3, which is 42.5, and I add that same number, what do I get?
83.75.
83.75. Any data points past 83.75?
Yes,
Yes.
80.
Yes. So 85 is a suspected outlier. And what we do in the situation of having a suspected outlier or more than one suspected outlier is we make what is called a modified box plot. And a modified box plot has one change to the regular box plot. There's no outlier on this side, 12.5. Sorry, it was 50, yeah, 15, not 12.5, sorry, 15. And then the next one was 22.5. And then Q3 was 42.5. That's all exactly the same. So what we do when we modify it is we put a star at the suspected outlier. And we stop our whisker at the last non-outlier. So the last non-outlier was 65. So we have our whisker stop at 65, and then we put a little star at 85. And this is called a modified box plot.
So Professor, in the case of a problem that had a suspected, a suspected outlier, will we have to modify the box plot every single time?
Yeah. I mean, if they ask for it. If they say,
Okay.
you know, you make the modified box plot, the answer is yes. If they say make the box plot, the answer is not necessarily. You do, you know, it's better to do it, but you don't have to do it.
Got it. Okay, thank you.
So I'm looking what else is here. Just a definition. The 5-number summary. The 5-number summary of a distribution is what 5 numbers have we been using so far today for these box plots?
5.
Well, not for our examples, but in general, how would I label them?
Min, max, Q1, Q2, Q3.
Yeah, the 5-number summary of a distribution, just writing them in order, is min, Q1, Q2, Q3, and max. That's the 5-number summary. Questions so far?
Professor.
Yeah.
I hate to backtrack, but can you please explain the 15 minus 41.25?
Well, 15 is my Q1, correct?
Yeah.
And 41.25 is 1.5 IQR, correct?
Oh, these are the extra steps. Okay.
Right,
Because
so
that was like,
right, so Q1 minus 1.5 IQR is the left fence. And
Mhm.
Q3 plus 1.5 IQR is the right fence. Anything past those is a suspected outlier.
Okay, makes
Okay.
sense.
Okay. So the IQR is one method of measuring spread, and there's another way of measuring spread. Another measure of spread is the standard deviation. Another measure of spread is the standard deviation. The formula for the standard deviation is more complicated than the IQR. It's not something that I would ever expect you or want you to do by hand. Luckily, the calculator can do it for us. But the formula for the standard deviation is as follows. First, the symbol that we use for it is S sub X. This is the sample standard deviation. Just like we have a sample mean as X bar, the sample standard deviation is S sub X. And what you do is you take every one of your data points and compute the difference between the data point and the mean, sample mean, and you square them and you add all of them, and then you divide by n minus 1, and then you take the square root. This is the standard deviation. Note the variance, which is S squared, is just the sample standard deviation squared. Why on earth would anyone choose to use this formula? This formula has incredibly pleasing mathematical properties that are, once again, significantly beyond the level of this course. The one major problem I have with teaching this course, as opposed to teaching calculus or teaching differential equations or linear algebra or all the other great stuff that's out there, is that this course, more than any other course, has a lot of, I can't tell you why, you just got to trust me. Because a lot of what we do, I can't justify it at the level of math that this course is assuming. This is another one of those examples. The sample standard deviation is just an amazingly mathematically pleasing formula for a measure of spread. SX is usually approximately a quarter of the range. This is a little guide that you can use to boost be in the right ballpark. That if you take the range and you divide it by 4, you get roughly the standard deviation. But again,
what's like the word definition of standard deviation? Isn't it just like how much it's like the average of how much a unit deviates from the mean?
Yeah, so basically it's a measure of how much a typical data point is from the mean. If you have a distribution like the following, if I give you a distribution like this, where is the mean of this distribution?
The center.
The center. And the typical data points here are far from the mean. right? They're on the far left and the far right. If I give you the following distribution, where's the mean now?
The center.
It's in the same place, but now the typical data point is close to the mean, if not exactly the mean, right? So this one is going to have a low STDEV, and this one's going to have a high STDEV, because it's a measure of how far away the typical data point is from the mean. When the data is far from the mean, a relatively high standard deviation. When the data is close to the mean, a relatively low standard deviation.
A measure of dispersion?
A measure of dispersion, that's correct. Mean always goes with STDEV. If you decide that the mean is the appropriate measure of center, then the standard deviation is the appropriate measure of spread. If you conclude the median is the appropriate measure of center, then the IQR is the appropriate measure of spread. They do not mix and match, ever. The mean goes with the STDEV, and the median goes with the IQR. And that concludes chapter 2. Which means the homework for chapter 2. I hope so, or we're done in this, we're just about done. The homework for the chapter is due next Thursday. So chapter 2 homework due February 10th. Chapter 1 homework, don't forget, is due February 8th. And the chapter 1 quiz is on February. Okay, go ahead. Is on February 8th. And you know what? We got to have a bunch of quizzes, so might as well have them when the material is easy. We'll have a chapter 2 quiz on February 10th. When the material gets harder at the end of the semester, you're probably not going to want to have a lot of quizzes then, especially when you're having, quizzes and tests and homework and other courses. So the more quizzes we can have in the beginning, the less quizzes we have to have at the end. So let's have 2 quizzes, one on the 8th for chapter 1 when the chapter 1 homework is due, and one on on the 10th when the chapter 2 homework is due. So that takes us to the end of chapter 2. We will do chapter 3, or at least start 3. I'll probably finish 3 on Thursday. And that's it. So I'm going to stop recording unless there's any other questions. We can go. We can vamoose.
It's not about the chapter, but you know how you said freshmen get the
Yeah.
how
So
you sent that email?
yeah,
I
yeah.
tried.
go ahead.
I don't know. I still don't know how to like sign up like to where it comes up like for free where I don't have to pay. Like
That- So the email, you're welcome, everyone. The email that I received as I passed on to you guys said that, yeah, I'll put it on YouTube in a few minutes. The email that I saw said that there should be no option when you sign up for Launchpad that requires you to pay.
So do I like sign up with my CSUN email?
Whatever email you want. Well, probably that's probably.
I signed up with my regular email and it gives me the option to pay. And
But maybe you're welcome, Amaya. Bye. I would try again with the other one and and see what happens.
all right.
Okay, because
Thank you.
again, it's beyond my knowledge, but as far as I know, you shouldn't have to pay for it.
All right.
Okay. Any other questions?
Quick question. So just to make sure it's
Yeah, Robert.
Q3
Yeah, go ahead. Go ahead.
for for Q3, it's always going to be subtracted by the IQR times 1.5. Right. And then the Q1 would be actually no, I'm sorry. Q1 would be the one being subtracted by the IQR times 1.5.
And Q3.
And then Q3 would be added to the IQR times 1.5.
Correct.
Just to make sure. Okay. Cool.
Yeah, that's exactly.
I found it, Professor. I just followed your link. like through
Okay.
Canvas, and it
It all works?
it didn't even give me the option to sign up. It just like took me straight to the homework.
Gotcha. Perfect. Everything worked.
Thank you.
The homework's on Launchpad. Will the quiz be there as well or on Canvas? I will link it to, I'll put it on Launchpad, but I'll link it on Canvas. But we'll actually do it, I think, in class. So like 15 minutes of class, I'll put it up and you'll do it on the spot. It won't be on your own. Yes, go ahead.
Professor, and in regards to both the homework and the quiz, how long is it looking?
How long is what looking?
Like the length of the homework or the quiz.
I mean, it depends. The quiz will be like 10 minutes. I mean, a couple questions. In terms of the homework, it depends. If you're going in without understanding anything, it might take hours. If you understand everything, it might take minutes. I can't answer a question like that. Right?
Okay. Is it open? Is the homework open right now?
Yeah, every homework for the entire course is open. And
Oh,
as we finish chapters, I will move the due dates to the appropriate day and then they'll close. So if you like already know statistics and are taking this course for whatever reason, you can theoretically do all the homeworks today. They are all already open.
Thank you. Have a good night, Professor.
You too. You too.
Have a good night, Professor.
All right, take care, guys. Bye.